So, good morning, good morning. So it's just getting in. We are just about to start the notes. As always, I am recording this. So, just a few housekeeping items. Oh, there we go. Got even more coming in. Awesome, guys. Thank you. Look, I know we didn't have school yesterday. Our folders in Schoology do not reflect that currently. So what is in Monday's folder before the end of the day, that will all be saying that's Tuesday's work today. Wednesday, tomorrow, we are just going to do the work that was intended for today. We're just going to skip Imagine Math this week just to get done what we need to get done with trigonometry. So again, thank you all for being here, and let's get started with our trigonometry notes. This is probably the last unit we are covering before the class ends. If you have questions, please utilize the chat. I can see the chat on my screen, and please make sure you're writing this down as well. I will post the notes, but please make sure you are getting this down somewhere, okay? So, here with this, we have a basic triangle here. So my angle right here, I call that theta. There are three different things happening here. We have the side that is opposite it. We have the adjacent side, that's a side that's next to it. And then we have the side that's across from the right angle. That is always the hypotenuse. So sine, cosine, and tangent. Oh, that's Mr. Vaughn. Thank you for that. So here with this, sine, cosine, and tangent are defined always in a right triangle using SOHCAHTOA. That's how we can remember it. So sine will always be the opposite side over the hypotenuse. So when I say so in SOHCAHTOA, that sine is opposite over hypotenuse. Cosine is always defined as adjacent over hypotenuse. So we're just creating that fraction. So adjacent over hypotenuse. So that's the CAH. C-A-H. Cosine is adjacent over hypotenuse. And TOA is for tangent. So tangent is opposite. Opposite, I used red. Sorry. Over my adjacent side. So in any right triangle, this is how these are all defined. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is always opposite over adjacent. So please make sure you have this down. I'm going to give you a moment to get that down, as Mr. Vaughn gave us a reminder, even though we are virtual. Please make sure you're writing down these notes. I'm going to double check. I know we let a few of you in as we started these notes, that everybody's attendance is accurate. Okay, so you get in, so you. That should be everybody fixed up. Give you about one more minute. No, 1 hour, 1 minute to get this down. Then we'll go on to our next group of examples. Okay, that was some time on that. So let's do. Sorry, computer. It's acting a little funny for me right now. Do this. There we go. That's what I'm going to do. Okay, let's take a look now at the next piece. So finding the values here. All we're going to do is leave these as fractions. So I want the sine of A, cosine of A, and tangent of A. So the first thing I'm going to do is I notice angle A is up here. So the side that is opposite is going C to B. The side that is adjacent to it is this side AC that is 6. And then my hypotenuse is always across from the right angle. That's my 10.82. So first thing I always want to do with these is label my sides, opposite, adjacent, and hypotenuse, so I know what is what here. And again, since they're all saying sine, cosine, and tangent of A, that told me, hey, it's always going to be the same in this, just base everything off of angle A. So we're just going to make them a fraction for each. So sine of A will be my opposite, which is 9, over my hypotenuse, which is 10.82. If you want the exact value, you could just put that in a calculator. I'm not going to stress that right now. I'm just going to say, hey, can we make the fraction correctly? Now we're going to do the same thing for cosine. Cosine now is adjacent over hypotenuse, so that is 6 over that hypotenuse of, it almost looks like it's a 16, not 10.82. And then finally, we have tangent of A, which is opposite over adjacent. So tangent will be 9 over 6. Now 9 over 6, we can reduce that if you wish to reduce that, since it's easy to see. They're both divisible by 3. That reduces to 3 over 2. So that is sine, cosine, and tangent off of angle A. I am looking at the chat, or you can unmute yourselves. Do we have any questions about how we found those particular values? So quickly, again, sine is opposite over hypotenuse. So that's where I got 9 over 10.82. Cosine is adjacent over hypotenuse. That's where I got 6 over 10.82. And tangent is my opposite, 9 over my adjacent of 6. So that's where I got 9 over 6. I saw that one was easy to reduce, so I went ahead and reduced that fraction. So let's go on to the next one. Again, we're finding the values of these. So here, now it's saying sine of B, cosine of B, and tangent of B. We're going to compare these answers to our previous example and talk about what that means in a second. So if I'm now at side B, or angle B, my opposite is now 6. My adjacent is now 9, but my hypotenuse remains unchanged. It's still the 10.82. So again, I'm starting with my sine of B. For the sine of B, that is my opposite, which is 6, over my hypotenuse, which is 10.82. 2. So that's 6 over 10.82. Cosine is adjacent over hypotenuse. So that's going to be 9 over 10.82. And then tangent is opposite over adjacent. So now this is going to be 6 over 9. Oh, 6 over 9, I can reduce that just like I did the last time. That reduces it to over 3. There we go. Got some more people popping on. To those of you that just got in, again, thank you for being here. What I'm going to do is I'm going to give you guys another moment to make sure you got this stuff down. We'll take a look at this example compared to example 1 in just a moment. Let me fix up the attendance for those that just showed up. Thank you for being here. There we go. So let's compare these answers. So sine of B was 6 over 10.82. Now, cosine of A happened to be the same thing. So here's what's happening here. If the triangle is exactly the same, but we switch what angle we're going off of, our sine and cosine values are essentially going to flip. So if you have two things that add up to 90 degrees, like A and B would, because we have that right angle at C, the cosine of A is going to be the same as the sine of B. The sine of A is going to be the same as the cosine of B. You notice again, those answers just flipped for sine and cosine, and tangent, the fraction, just flipped. So just some side notes there, but for right now, when I'm finding the exact value, oh, I'm just doing opposite over adjacent for tangent, opposite over hypotenuse for sine, and adjacent over hypotenuse for cosine. So now we are going to find the missing side here. We are going to need to use the Desmos calculator here. There is an important thing we have to look out for, but first, let's set up the problem. So right away, I know I have this angle here. When I look, this side X is my opposite. This side 12 is my hypotenuse. And the side we don't have anything with is the adjacent. So right away, I notice I have opposite and hypotenuse have information. So since it's opposite and hypotenuse, that tells me my function should be the sine. And my angle is 35 is equal to my opposite, that's X, over my hypotenuse, which is 12. Now we just need to solve this. We are trying to solve for X. So if I'm trying to get X by itself, if I'm dividing by 12, all I have to do is multiply both sides by 12. So I get the X is equal to 12 times the sine of 35. Well, 12 times the sine of 35 sounds all well and good. So let's get going and see what that it actually is. So there are a few little things to keep in mind here. So I go to my Desmos calculator. There's one thing we have to do pretty much every time you're opening this, you're gonna have to go and do this. So we want to hit the wrench right in the upper left hand or upper right hand corner. It's in the same spot if you're using the app on your phone as well. And over here at the bottom, it says radians and degrees. Radians is another way to measure an angle. You'll learn about that more in maybe IM3 if we have enough time to cover that, but you'll definitely learn about radians in pre-calc. Radians are just a different unit of measure. But right now we're doing everything in degrees, so you need to click degrees. Because we'll notice that if I just type it in, now we can find it on the keyboard. Under functions, you can do sine, cosine, tangent. There are some other trig functions in there that we'll get to in the future. There we go. So here, I'm just going to use sine of 35. I said 12 times that. So 12 times sine of 35, and it spits out an answer for me. Now notice, if this is in radians, that number changes very quickly. We have to be in degrees for it to work, right? Because that's the unit we're working in. So I just put that 12 times the sine of 35 into decimals. It tells me that side length is 6.88. So let's just write that down. X equals 6.88. And that's finding that missing side. Got two more examples on that. But if we're just trying to find the missing side, or this is what we're doing. We're going to set it up and then solve for X. Desmos is going to do our calculations for sine, cosine, and tangent. Way back in the day, they had tables of all these values. We don't have to stress that. The calculator's doing a lot of the heavy lifting. Any questions on this one before we look at the next one? Sorry.
Isaac, can you repeat how you went over decimals? I didn't really see how you did it.
Yep.
Like, I didn't really see.
Okay, so let's start that from the very beginning. First thing we need to do is make sure we're in degrees. So I hit the wrench in the upper right-hand corner. Usually radians will be where it's at, but I want it in degrees, so I just click where it says degrees. We need to make sure that's done, so that's in that upper right-hand corner with the wrench. Flip it from radians to degrees. Then we had said 12 times. Now you can literally just type out sine and it will know what you're saying. Or you can use under functions, it has everything inside a trig and you can just click on what you need. Sine of 35. And it just spits out the answer. So I just typed it in 12 times the sine of 35, just like I wrote it here. Make sense?
Oh, God.
Cool. Let's look at the next two examples, very similar to this. Okay, so here with this, right away, I have this angle here. So I notice that the 7, that's an adjacent side, and the X is the hypotenuse. Technically, the side AC with nothing on it is the opposite, but I don't have to stress about that because I don't have information there. Where I have information is at the adjacent and hypotenuse. So adjacent and hypotenuse is cosine. So that's going to be the cosine of 42 is equal to my adjacent side, which is 7 over x, which is my hypotenuse. Now, this one's a little trickier to solve. When x is in the denominator, there's a neat little thing we can do. The math behind it is essentially I would multiply both sides by x, and then the x times the cosine of 42. Well, since that's being multiplied, I would divide to undo that. So what I'm actually just going to do, I'm going to do that in one motion here. I'm just going to switch the cosine and the x. So this will now become x equals 7 over the cosine of 42 degrees. So really I could say, oh, let's multiply by x and divide by the cosine of 42. That's a more formal way to do it, but we realize, hey, it's going to work that way each time. Found a shortcut here to say, hey, I can swap the x in the denominator with the cosine that it's equal to. So now 7 over the cosine of 42. This is just utilizing the calculator. Now, since we already have it in degrees, I don't have to flip it over again because I'm still doing my work. Sorry about that. So now just type it in how I had it written. That was 7 over the cosine of 42. And look, it just gives me the answer. I'm not stressing about too much more than what it says here. So that's 9 point, that would get rounded up to 42. So again, I did 7 over the cosine of 42. And that's just equal to 9.42. And that's my answer. That's okay. You're here now, and I will get your attendance fixed in a second. And I also have this being recorded, so you can go back and look at the earlier stuff as well. Thank you guys for being here. Any questions on this example of finding the missing side? You're welcome. We've got one more where we have to find the missing side. And this one is going to use, if you guessed it, probably tangent, because the first one used sine, next one used cosine, so it makes sense to look at one that involves tangents. So here with this. This is, I'm starting with angle A, so 12 is opposite. X is my adjacent. And my unknown hypotenuse is over here, but I'm not worried about the hypotenuse, so I'm not going to do anything with it yet. So, since I have opposite and adjacent, that goes back to cosine, or that cosine tangent. So remember, utilizing SOHCAHTOA, that's our big thing right here. Sine will always be opposite and hypotenuse. Cosine is adjacent and hypotenuse. Tangent is opposite and adjacent. So that's what I'm going to utilize here, tangent. I'm going to say the tangent of 53 is equal to my opposite over my adjacent. So opposite is 12 and adjacent is x. So this is another one. We have that x in the denominator. That's when we're going to do that fancy swap. I'm going to move tangent of 53 to the denominator. The x is going to move out in front. So that's going to be x is equal to x is equal to 12 over the tangent of 53. So again, the tangent of 53, you're not going to know that off the top of your head. So we're just going to have to utilize the calculator. So again, I know I'm already in degrees, but please make sure you are in degrees when you start doing your work. If you're in radians, again, we'll see these numbers change greatly. So we don't want to be in radians. We always want to be in degrees. So that was 12 over the tangent of 53. 12 divided by, now you could just type out the word tan if you want, or you could go functions. Under trig, you'll see sine, cosine, tangent. Just click on tangent of, then type in the degrees, 53. And we get 9.04. It's 9.04. And that's it. So you do have some work related to this in Schoology. Let's quickly bring that up. Schoology. Okay, let's go to your class. So here with this, we're actually in Monday's notes. Even though today is Tuesday, all of this will be changed to reflect the fact that we did not have school yesterday. So Monday is now going to move to Tuesday. Tuesday moves to Wednesday. Wednesday is completely scratched. Thursday, we'll get to finishing our word problems. And Friday, we'll work on a little review with the trig, wrap up our last unit so we can have a quiz before the end. So if we go into Monday's folder again, what's in Tuesday's folder will be moved to Wednesday. You're not responsible for that. Due dates will be adjusted accordingly as well. Under major activities, again, I'll put the completed notes and the recorded lesson in here as well. But if we go to the trig intro practice, already see somebody took the time to do that. Thank you for that. Look that over in a second. That opened up over here. So here with this, as I look at this worksheet, we just have, writing it out like, oh, go with the angle you have. So that sine of C, do opposite over hypotenuse. That's the first group of problems. This group of problems, you're literally just typing it into the calculator. Make sure you're in degrees. 1 second, I'll get to that question in a moment. And then the last group is just like what we were just doing. So that is what we have. Let me stop recording. We'll get to that question. Okay. So, when are we coming back into the building?